I'm going to run through ENFSI exercise 2 again. This is a major minor profile where the minor contributor is evidential. The case circumstances are as follows. A policewoman was raped in a city of Europe and a suspect was detained after a few hours. The pathologist took a penile swab from the suspect and sent it to the DNA laboratory. The judge wants to know if the policewoman contributed to the penile sample taken from the suspect, and reference samples from the victim and the suspect are available for analysis. So the next step is to view the evidence here, and that gives us the EPG over here. You can see we've got a major minor profile. Label 1 here is the ENFSI suspect. Label 2 over here is the victim, so you can see that the minor component belongs to the victim under the prosecution hypothesis. And over here we have the degradation analysis, so you can see that there is a reduction in the peak height relative to the average fragment length, and this leads us to believe that there may be some degradation in this profile. So the next step is to carry out the analysis. So under the model specification tab, we click on the suspect and the victim under the prosecution hypothesis, and under the defence hypothesis we're conditioning on the suspect because it's a penile swab, and we make sure that the no buttons are clicked for the degradation and stutter model options, and then we click on the continuous LR button, and then this gives us the GUI underneath the MLE fit tab. So over here under the prosecution hypothesis we have the two contributors. We've got the suspect and the victim respectively, so we've got about 80% of suspect DNA and the remainder belongs to the victim under the prosecution hypothesis. Similar figures obtained under the defence hypothesis over here, and we are interested in the log likelihood over here. It's minus 306, so we'll be using this parameter to determine the best model to report. And let's note the likelihood ratio is log 10 to the log 10 10.89. The next step is to try several different models. So here we use the model without degradation and without stutter. The log likelihood was minus 3.06. Then we try model with degradation without stutter, and the log likelihood is minus 301.4. Now each time we introduce a new parameter we have to penalise this number by subtracting minus 1 from it. So this would be adjusted to minus 302.4. Next we try a model without degradation with stutter, and this gives a log likelihood of minus 305.6. Again we penalise this with minus 1, so the log likelihood is adjusted to minus 306.6. And then finally model with degradation with stutter, and this is penalised by minus 2 because we have two extra parameters here, and this would be minus 303.4. So what we're looking for is the maximum log likelihood, and that is clearly this one, a model with degradation but without stutter, and that gives us an overall likelihood ratio using MLE of log 10 11.35, and you notice that all these likelihood ratios are actually pretty similar to each other. So the next step is to choose the model with degradation but without stutter and reanalyze the data. So here we can see the mixture proportions as before, the log likelihood here which is maximized, and the likelihood ratio, log 10, 11.3. So the next step is to carry out model validation, and we press these buttons here and here, and then we examine the points and the PP plot, and there should be a reasonable, more or less straight line, and they have to be encompassed by this envelope here. The points have to be encompassed for the model to be a reasonable fit, and as you can see, for both the defence and the prosecution hypotheses, they both give pretty good fits. So that means that we can trust that the model is giving us a reasonable answer. So the next step now is to carry out the LR sensitivity test, and what we do here is we carry out a simulation using MC across the parameter space, and we're reporting the 5% quantile, which is over here, as the likelihood ratio that would be reported, which is log 9.75 in this case. And it's interesting to compare this answer with an analysis which is carried out using EuroForMix Studio, where the log likelihood ratio gives us an answer of log 8.98. So these answers by these two different pieces of software are fairly similar to each other. Now in the next talk I'm going to talk about some more complex analyses using the same data and carrying out further comparisons with EuroForMix Studio.